Okay, right. Now this is the calculation from the book, right? The book asks, so we have to, I have to teach you like what they ask, because whether it is inside your syllabus or not, maybe the textbook knows clear. The revision book, maybe they are not the textbook writer, so they don't know whether it is inside the syllabus or not. Okay, so we look at self exercise 4.2. You read question number 3.
Pardon,
Lee,
teacher?
read question number
Uh,
3.
what is the number of ways to arrange seven customers to sit at a round table in a restaurant?
So 7 customers, arrange them in a circle, a table, a round table. So how many ways can you lift up the customer and put them upside down? People, you
No.
cannot do like that, right? People, you cannot do like that. So you cannot do like that. This one cannot be the ring permutation or the bracelet or the necklace. It cannot be like that. So in a circle, you have 7 people, so you use 7 factorial, right? 7 factorial. Then because it's a round table, you divide by 7. So 7 factorial divided by 7 is 720. Okay. You read the number 4.
Determine the number of ways to arrange eight gemstones with different color to form a chain.
This one is a chain. So it's a chain. Uh, so it's things that you can take out, wear, then take out again. Then sometimes you wear terbalik, then actually it's the same. It's the same, right? Whether you wear like this or you lift up, then you wear it the other way around, it's the same, right? So how to find the number of ways to arrange 8 gemstone? Is it? Gemstone, correct. So 8, you have 8 factorial, right? 8 factorial. And because they are arranged in a circle like that, you divide by 8. So 8 factorial divided by 8. Why is there an extra 2 that I write in red color here?
Because will repeat.
Because you can take them out and wear them, take them out and wear them. So there's a, when you can flip over the other side, it's the same arrangement. So to get rid of the flipping, you divide by extra 2. Next one, you read the question number 5.
An employee at a restaurant needs to arrange 10 plates on a round table, but the table can only accommodate 6 plates. Find the number of ways to arrange the plate.
This one how? There are more plates that can be put on the table. You have 10 plates. You only want to put 6 of them. So this one, they have 2 conditions there. The first condition is you permutate n permutate r. But n permutate r and you have to permutate them in a circle, right? So how to do this? Can you still remember how to do n permutate r? The number of objects is different than the number that you're going to permutate. So because you want to 10, you want to permutate 6 of them. So you start from 10. 10, 9, 8, 7, 6, 5. So you permutate all these 6 objects. But because they are arranged in a round table, you have to divide by the number of objects, 6. Okay? And you have 2, 5, 2, 0, 0. Any question from here?
No, teacher.
No, no. No, then you look at this question here, number 4. Can you read question number 4?
A family consisting of a father, mother, and 4 children are seated at a round table. Find the number of ways they can be seated if there are no conditions. The father and the mother are seated together.
So how?
6 factorial over 6.
Correct. Because there's how many of them are? Father, mother, 4 children, there are 6 of them. 6 people you want to arrange in a round table, it will be 6 factorial divided by 6. That's all. Okay. But for the second part, father and mother, they must be seated together. You cannot have a child or 2 children in between the father and mother. Okay or not? You cannot have somebody in between them. So if that is the case, how many ways can they be seated in a circle? Well, the
Teacher, I don't know leh.
again,
I don't know.
don't know, don't know. Right. Um, Now you consider a round table, right? Round table like this, round table like this. Then you have here father, then here mother, 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 father and mother. Then around the circle here, the other places around here, or maybe I don't want this. Okay. Now the other places there, how many places around the table? I mean, after the father until the mother, how many people are going to sit the other side here around the table? 4 children, they have to sit here, right? So 4 children, I will say child number one, child number one, child number one. Okay, or I can have child number two, or I can have here child number 3, and I have here child number 4, right? These 4 people, the 4 children, they are seated around the table here. Okay, right. Now these 4 children, how many ways can they be arranged? How many ways? 4, they sit here, it will be 4 factorial. It will be 4 factorial, right? But the thing is, the father and mother, okay, the father and mother, they can actually interchange the place. They can actually interchange the place. Okay, so the other arrangement will be the mother sit here, mother sit here, then the father sit on the other side, father sit on the other side. So in this case, right, here will be 4 factorial. These 4 children seated here, it will be 4 factorial. This side will be 4 factorial. Okay, then the mother, father, they fix this way. Then another way will be the mother sit on the right side, father on the left side, right? So this one also 4 factorial, also 4 factorial. So the total number of ways actually is 4 factorial plus another 4 factorial, and that will be 2 times 4 factorial. Okay, 2 times 4 factorial. But we can say that this 2 is actually the number of ways in which you can arrange the father and mother. This is the range. So actually the 2 here means 2 factorial, right? 2 factorial, and the children can be arranged in 4 factorial. That's why I have 2 factorial multiply with 4 factorial equals to 48. This one is not the correct way, right? So it should be like this, right? 2 factorial multiply with 4 factorial. Where the 2 factorial come from? The 2 factorial come from here, the arrangement of father and mother. This father, mother, or mother, father. So there are two ways of arranging them. So it's 2 factorial for arranging the father and mother. Then 4 factorial for arranging the 4 children. So we have 4 factorial times 2. 4 factorial times 2 is 48. Any question? Is my drawing clear here?
Yes, it's clear, teacher.
Clear, ah? So the 2 factorial come from the father and mother arranging among themselves. The 4 factorial come from the children arranging themselves. So we have altogether 48 ways, right? Okay. Uh, that's all for today. If you have no questions, then we stop here.
Okay, teacher. Thank you, teacher.